So Chapter 13 focuses on simple interest. And so this chapter is really important if you've ever taken out a student loan, a car loan, a home loan, or you plan on doing this in the future, which most of us probably will. And so interest is basically just the cost of borrowing money. So if you go to the bank and borrow $10,000, they're not just going to give you the $10,000 and you pay it back, say within 5 years. They're going to charge you an interest rate that's based upon the bank and also your credit score. And so here we have Don, who borrowed, let's say, $1,000 for 1 year at a rate of 8% simple interest. So to compute the amount of interest that he's going to have to pay back, in addition to his original loan amount, we need 3 things. We first need the principal amount, and so your principal is simply the amount of the loan. In this case, it's $1,000. Okay. Another thing you'll need is the rate. The rate is the interest rate that's given. Here it's 8%. And then finally, time is the length of the loan. And in this case, that's 1 year. And so it actually calculated it for us that to calculate the interest using this interest equals principal times rate times time formula, you'll simply take $1,000 in principal times the 8% simple interest, and then times 1 for 1 year. And this gives us $80. So $80 is the interest, and if we wanted to figure out the total amount due at the end of this year, this is also called your maturity value. You'd simply take the amount of the loan, which was your principal amount of $1,000, and you would add the interest, and in this case, our maturity value, or the amount due in total at the end of the year, is $1,080. Okay, let's take a look at these next examples. For example B, we're going to see how time really makes a difference when we're dealing with interest. And so we have time periods of 3/4 of a year. I'm just labeling that with a T, and also 4 years. Okay, the loan amount or principal is $1,200 and our rate is 6%. So the main formula that you'll be using this week is your interest is your principal times your rate times time. So I want to calculate how much interest we would have to pay if our term or the length of the loan was only for 3/4 of a year. So remember, I'm taking my principal amount of $1,200. I'm going to multiply that by 6%. And time is expressed either in whole years or fractions of a year. Okay, so times 3/4. And this is $54. So a $1,200 loan at a 6% interest rate for 3/4 of a year will accrue a $54 in interest. If we had a time period of 4 years to pay off this loan, I'm still taking my $1,200 times my rate of 6% and times 4 for 4 years. Again, recall that time is expressed in years or fractions of a year. And so this equals $288 in interest. And so we can immediately see here that it doesn't matter if the principal and the rate is the same. The longer you have to pay back a loan, the more interest you're going to need to pay back. Okay. And we can do the same thing for example C. So let's say that we have a loan amount or principal of $3,000, a 5% interest rate, and then here we're going to have months. Whenever you have months, because we're dealing in fractions of a year, we use 12 as our denominator when inputting our time value. So I'll first do for 8 months. Again, I'm taking my principal amount, that's $3,000, times 5% times 8 over 12. And this gives me $100 in interest that I'd have to pay back. If we had a period of 30 months, again, I'm taking my principal amount times 5% times 30 over 12. So it's totally fine that this is an improper fraction. And let me take out my calculator for this. So that's 3,000 times 5% and then times 30 divided by 12, which gives me an interest amount of $375. And so here again, we can see that the longer the length of the loan, the more interest you'll have to pay. And so this next slide, it just shows the calculator steps for computing simple interest. Okay, and so notice that when you use the percent key, there's a little bit less or one less step that you have to take, and that's just you don't have to manually convert that 9% into a decimal. You can use your percent key as you've learned in the last few weeks in this class on your calculator. Okay, and so we can see the difference here if I enter it as the first way with $800,000 or $8 million times 0.09 times 18 divided by 12. Okay, so that gave me $1,080,000. I could also do 8 million times 9% and times 18 divided by 12, and again that gives me $1,080,000. Okay, so again, I just like to use the percent key on your keyboard or on your calculator rather, because it reduces the chance of error, especially when you're converting percents. You don't want to accidentally enter 0.9 for 9% or 0.009 for 9% when you convert that to a decimal. Okay, now I have two more examples here, and the first example is going to be computing ordinary interest. And so ordinary interest uses a 360-day calendar. And so ordinary interest was actually used in the past long before calculators were invented, because although obviously there are 365 days in a year, when you're calculating this many days, it's easiest to just have rounded it to 360. Okay, so just remember, if you ever see computing ordinary interest, that is going to be using 360 days. Okay, and I actually remember it because of the O in ordinary looks like a 0. Okay, and so ordinary interest is used when we have days as our time. So if we have a loan amount or principal amount of $900 at a rate of 9%, and time now is 120 days. Okay, we'll take that $900 times 9%, and then for time, I'm taking 120 days over 360. And this is going to give me an interest amount of $27. Okay, and now let's see what happens when we compute exact simple interest on the same loan amount, rate, and time. Okay, whenever you see exact interest, that's when we're using the exact number of days in a year, or 365, as our denominator for time. So I'll take my $900 in principal amount times 9%. And then for my time, that's 120 days over 365. And so if I round this to the nearest cent, that is about $26.63. Okay, and then so you can see that with ordinary interest, you're actually paying more, but just slightly. So be very careful when you're completing this week's word problem assignment. Look for the words ordinary or exact so that you know if you have to use 360 days or 365 days. Okay, and so let's compare them again. So we're going to find the difference between ordinary interest and exact interest on an $8 million principal amount at 9% for 120 days. Okay, so I'll write ordinary on this side and exact here on the right. Okay, so I'll take my $8 million times 9%, and because I'm doing ordinary here, that's going to be times 120 over 360. And with ordinary interest, this is $240,000. Okay, for my exact interest, again, I'll take my $8 million, multiply that by 9%, and then my time, again, is 120 over 365. This is going to be 236,000. Oops, let me fix that. $236,712, and rounded to the nearest cent, 33 cents. So again, we can see that with ordinary interest, it's still slightly more than if we had used exact interest. Okay. Another thing that you'll be doing this week is estimating exact simple interest. And so there's actually a table for this, but let's say that we want to approximate the ordinary interest on $2,500 at 6.15% for 59 days. Then we're going to calculate the actual ordinary simple interest. Okay, so 13.1 or 13-1 is a table in this week's chapter. And so here we're going to use an estimation based on what we're given in the questions. And so I want to take a look at where we have about 6% interest. So recall that the interest amount or the rate was 6.15%. And so that can be rounded to 6%. And then we also had a time of 59 days. And so 59 days can be rounded up to 60. Okay, and so if you take a look at the second one here, we have 6%, so if we rounded 6.15% to 6%, times 60 over 360, and that's because we rounded the 59 days up to 60. What we can do is simply multiply by 1%. And so if you see here, and let me take out my pen, if I take this $2,500 loan and multiply that by 1%, this gives me $25. So $25 by estimate. If we want to calculate the actual ordinary interest, here we're going to do our regular formula of principal times the rate times time, and because this is ordinary, I'm using 360 as my denominator. And so let's take a look at this on our calculator. So I'll take 2,500 times 6.15%. That'll give me 153.75 times 59 divided by 360 gives me $25.20. Okay, so I think there's just one of those problems in this week's word problem. And so just be careful when you're using this table here that's in the e-text that you only multiply the principal amount by whatever percent is listed here at the end of the columns. Okay, so if you rounded to something that was closest to 8% and then closest to 45 days, you would multiply the principal amount again by 1%. Other problems you might run into in this week's word problems, ones in which you have to calculate both the exact simple interest and the estimated, as well as to find the difference between the actual and the estimated. And so if we take a look at this example that's already done for us, so let's say we have a principal amount of $1,200, a rate of 11.8%, and a time of 62 days. So because it was asking for exact simple interest, that came out to $24.05 because we used 365 days as our denominator for exact interest. And so when we estimate, again, we're going to use that 13.1 table in your e-text. So what we can do is to round this 11.8% to 12%, and we can also round the 62 days to 60 days. And so now if you go back to that table and look for 12% and 60 days, okay, that's going to be multiplied by 2. So there's 2%, it says. And so that's how it calculated this, which came out to $24 as the estimate. And so to find the difference between the actual and the estimate, you simply subtract the estimate from the actual. And in this case, there is only a 5-cent difference just from your estimation. Okay. And so just by knowing our interest formula, remember that's your principal times rate times time, we can also rewrite it to find our principal amount, your rate, and your time. And so notice for each of them, your interest amount is your numerator, and then the other two things that are known are going to be multiplied in your denominator. So if you know your rate and time and your interest and you need to calculate your principal amount, you would use this formula. If you need to calculate your rate, you can do that by taking your interest amount and putting that over your principal times time. And then to calculate time, you're taking, again, your interest over your principal times your rate. Okay, and so in this case here, it's saying to find the principal. So we don't know what the principal is. So P equals, we know our interest. Remember that your interest is always your numerator, and your denominator is 6%. So that's my rate. And my time is 30 days. And so that's 30. And here I'm going to use ordinary interest, so over 360. And it's important that you calculate your denominator first. So 6% times 30 over 360 is 0.005, and I'll just double check my calculator, okay, which it is. And so my numerator is still 75. Remember that was my interest amount. And 75 over 0.005 is $15,000. So this tells me if my interest is $75 and the rate was 6% and time was 30 days, my original loan amount, or my principal, was $15,000. Okay, here it's asking us to find my rate. So R equals, okay, interest is our numerator. Okay, our principal was $2,000. And again, I'm just going to use ordinary interest. And time was 30 days. Okay, so make sure you calculate your denominator first. And 2,000 times 30 over 360 gives me $166.67. My numerator is still $22. And so this gives me 0.132. Because it's asking for the rate, remember that this is a percent. So to convert this to a percent, this equals 13.2%. Okay, and let's do the final example, which is calculating time. And so time, we have our interest amount of $324. My principal is $4,800. And my rate was 9%. Okay, so this still gives me 324 as my numerator. My denominator is $432. And this is going to give me 0.75. But remember, we're finding time, and as I mentioned, that time is expressed either in whole years or fractions of a year. And so to convert this into days, okay, and we're basing this on a 360 day of the year, we need to multiply this 0.75 by 360, and this is going to give me 0.75. Okay, but we've never really had a time with a decimal. And according to this question, it says based on a 360-day year. So what we need to do is to convert this decimal into days. And because this is based on a 360-day year, we're multiplying that by 360, and 0.75 times 360 is 270. So time is 270 days. So 270 days was the length of this specific loan.